is this this trend of like spreading like fire everywhere across the world? So we'll go through the examples of machine learning to understand that how it creates magic. We'll also understand the learning plan and curriculum. What do we have in the courses that we are going to conduct? We are just going to get our feet wet into one of the machine learnings, which is a starters for a machine learning enthusiast, like linear regression. And then we will introduce ourselves to some of the machine learning algorithms that we are going to go through in the course. And we'll appreciate what are the nuances in that, including so the training, the USP for us is that we don't only tell you how to code, we also share the mathematics behind the algorithm, which is very important. Okay, then we'll also introduce deep learning. What is deep learning? And we'll also appreciate the differences between deep learning and machine learning. Okay, last but not the least, we'll share the course details and the exclusive offer for webinar attendees. Okay, okay. So let's start from what is machine learning. So if you understand machine learning and divide the two terms and understand individually what is machine and what is learning, so it's basically you are training the machine or training a computer to learn from data. Like humans have like in retrospectively, humans have always learned from experiences. As you see and as you grow, you learn more experiences. You have your brain grows into understanding different things. Similarly, you are allowing the computer to learn from the previous experiences or the previous data that you have, and allowing him to understand the data and predict something in future. Now, it may not be always predicting. So people always think that machine learning is all about predicting. It may not be just predicting. You may also be creating insights from the existing data. So we'll come to that, how you would bifurcate machine learning between a supervised environment and an unsupervised environment. But that discussion will be stated for later. Machine learning, a very brief definition, is a type of artificial intelligence that provides the computers the ability to learn without being explicitly programmed. Okay, now this part where we are saying without being explicitly programmed is a very, very important term, right? So in a wider sense, if you understand this in such a way, let's say artificial intelligence is a bigger ball, okay? And within that, there is machine learning, which is a subset of artificial intelligence. So artificial intelligence can be a robotic process automation, okay, or any type of exploratory data analysis. All these is artificial intelligence. It's something which is being created by a machine, okay? And machine learning is a subset of artificial intelligence, is a very specific form of study, okay? And deep learning is a subset of machine learning, right? Deep learning is not exactly different. It's not a superset. It's basically a subset of machine learning. Okay. Now, how is a traditional programming different from machine learning? So let's understand this. So for example, if you have an input data, traditionally what we had is we had a program, and then there is an output data. So for example, let's say you have a chair, okay, and the chair has four legs, okay. So let's say you have programmed a logic which identifies whether this object is a chair or not, okay. Now let's say the chair has 4 legs. So what you have explicitly programmed is whenever an object has 4 legs, it will be a chair, okay. Now this looks a good algorithm, but it will fail if it sees a table, okay. A table can also have 4 legs. So what you're trying to avoid in a traditional program is you don't want to explicitly program. You don't want to give very hard coded features that, hey, if this happens, then this is the result. If this happens, this is the result. You cannot achieve all the possible combinations in this universe to explicitly program anything, right? So to go away with that pain of explicitly programming anything, what you're doing is you're allowing the you're allowing the computer to learn from the input data. So you have given whatever has happened till now, whatever data you have in the organization, you feed it to the machine learning program. You will feed it to the machine learning algorithm, then it creates a program. Okay, now this program, it can be used for further data, whatever it comes in the future. I can use that data and use this program to find the output. Okay, now this will not be very clear at this point of time, I understand that, but we will slowly and appreciate the differences between explicitly programming and machine learning technique. Any questions till now? Okay, so I'm assuming we don't have any questions at this point of time, so let's progress. So as I said, that machine learning is widely, I would say, bifurcated into two types of study. One is the supervised learning, and other is the unsupervised learning. Now, can anyone tell me what is the difference between a supervised learning and unsupervised learning? Any guesses?
Supervised learning is basically.
Sorry, come again. Yeah, Aish, we are not able to hear you.
Supervised learning include trained data, train output, and unsupervised learning. We have
Okay, so yeah,
So basically,
as much as I could.
in supervised
Yeah.
learning, sir, what we see is it is all about structured. It is structured, especially it is basically based on classification and regression, and we surely get an assured outcome, like say it's in the form of true or false or something like that. Unlike in supervised learning, for example, I could give an example of like the suggestion we get from YouTube or Netflix, like that.
Excellent. So that's very well put. Thank you. So I think Tanuja also mentioned in chat, and I think she has very clearly explained. Supervised is something with labels, data with labels. Unsupervised is data without labels. Very clear and distinct. And thank you for the examples like YouTube and Netflix. Now let's understand unsupervised first. So unsupervised is something which you don't know the output. Okay, so you have some data. Let's say you are collecting the heights and weights of a group of people who are coming to you, and you're randomly noting down their heights and weights. Okay, now suppose you forgot to mention whether that guy was a male or a female. Okay, now you take this data to your and you start to analyze, right? So if in retrospective, if you have not mentioned who was a male and who was a female, in the future, if anyone gives you a data of an height and weight, you'll not be able to predict, because you never knew what height and what weight was pegged to what gender, right? And now also you just have the height and weight, so you cannot predict anything. However, what you can do is you can do an unsupervised learning, basically a clustering, and understand that height and weight clustered, and if clustered in 2 dimensions, I can have, let's say, 2 clusters. Now these 2 clusters are hypothetically, I would say they are different, and hence I can say whether they, one is male or a female. But this is an unsupervised learning. Recommendation systems like YouTube, right? They don't know whether whatever they are giving you or suggesting you, they don't know whether that's right or wrong. They don't have a supervision to it. They have all the data of your searches, whatever you have searched in the past, and they have their algorithms, and they are basing some suggestions on whatever you have searched on the net. Now they don't know whether this is a very good or this is the right approach, or this is I would say this is the right suggestion or the wrong suggestion. They don't know the supervision, so they have done an unsupervised learning. However, when you are predicting something, let's say whether the stock price of the stock will increase or decrease, what will be the price of the stock, whether the person is a defaulter or not. So something which is related to a fixed output. You know that this guy is going to be fraud or not a fraud. You're not telling, you have a very supervised environment, right? So as rightly said by someone, supervised learning have two categories. One is the regression, the other is the classification. And unsupervised learning mainly, you could say, can be divided into two forms: clustering and principal component analysis. Now, we'll not go into unsupervised learning too much detail in this particular webinar. However, it will be a part, important part of our training. Okay. Now let's understand supervised learning. So, what is the difference between a regression and a classification?
No idea, sir.
Okay. Anyone else? Someone who had mentioned that supervised learning is a regression and classification. Can you explain what are the differences? Excellent. So Tanuja has rightly said that regression is for continuous output. It's basically a numeric. So a very clear example here is, let's say you are trying to predict whether the stock price will increase or decrease, a yes or no. What type of problem is this?
Sir, supervised.
It's a supervised, right? Okay, let me rephrase the question. If you want to predict whether a stock price will increase or decrease, very fixed outputs, yes or no. Excellent. It's a classification problem. You're not saying how much it will go. Let's say the price of the stock is 100 rupees today. Will it be 10? Will it be greater than 100 or less than 100? This is a classification problem. Now, what absolute value would it be? Let's say 105 or 104, or let's say 98 or 97. This is a regression problem where you have a continuous numerical output. And a classification is a very fixed outputs. Now, fixed outputs can be many, like it can be yes, no, maybe, or even it can be like a IMDb movie rating, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, a very fixed sets of outputs. Okay, it's not a continuous output. It cannot, the output does not range from -infinity to infinity. It has a very fixed range. Okay, so that's the difference between a classification and regression problem. Now, just match the following to a regression or classification. Let's say first one, the email spam filter, whether the email is a spam or a not. What kind of problem is this?
So regression.
Why? Are we predicting any numeric output? No, right? It's a classification. Because we are saying whether it's a spam or not. Just two things. I'm not concerned with any numeric quantity. Okay. Okay. Stock price of a stock in future.
Sir, regression.
Very good. Because I'm saying the stock price. Okay.
Yes, sir.
So it could be 101, 101, any 101.25, anything. House price based on its attributes.
Sir, again regression.
Regression.
Correct. A person is diabetic or not based on blood report.
So classification. He'll
Excellent.
either be or he'll not be.
Correct. So in essence, you have got the hang of it, right? So now keep this in mind, right? Classification may not be just binary classification like yes or no. It can be like, for example, if I have been given a picture and I want to say whether it's a dog, cat, lion, tiger. So it can be any number of classes, right? But it's a very fixed output. You cannot have dog 0.5 or cat 0.2, right? It's a very set of outputs, whether it's a dog, cat, tiger, or lion, right? Okay.
Yes.
Okay. Now, as I said, that applications of machine learning are infinitely many now at this point of time. And what we have is, let's say, you have wherever there's a plethora of information like social media, search engines, healthcare. Can anyone tell me how healthcare can deploy machine learning? Any guesses?
Through robotics, we can tell about anyone have a disease or not.
whenever, see, now keep this in mind, whenever we are thinking of applications of machine learning, right? Now, since I have my work experience 4.5 years, what I've learned here is whatever is being done by a human at this point of time can be replaced by a machine, okay, using machine learning. So for example, if there's a doctor who is trying to predict whether the person has cancer or not, does not have cancer, using his report, so staying from the reports or an MRI scan or any CT scan, whatever scan, now this thing can be replaced by a machine. What if there's a nurse filling the forms of insurance, right? This can be replaced by a machine. So wherever there's a human intervention, wherever there's a human present, that human can be always replaced by a machine learning. Now, to what extent, to what efficiency, that depends on the application. That depends on the efficiency of your code. Okay. Surgery, right? So surgery is being done by a doctor, that can be replaced by a machine. Okay. So anything, cars is being driven by a human, that can be driven by a machine. Okay. And whenever there's a human involved, there are why in first place there was a human involved, think like that, because it's not that the person is following a set of SOPs, right? A doctor does not work on SOPs. He has his own brain, he has his own knowledge. So he has read for, let's say, 10 years, 15 years, he has gained experience, and he is determining the disease of the patient from his experience, right? Now, if there would have been a very easy thing, let's say blood pressure greater than 160 is hypertension. Okay, if you just have to predict this is very simple. You don't need machine learning here, because I know whenever the value is greater than 160, I need an if-else statement, and I can say if BP greater than 160, this is hypertension. But BP combined with sugar, combined with cholesterol, combined with ECG, combined with etc., etc. Now this becomes complex. Now this you cannot implement all the possible cases in using an if-else statement. That's why you cannot use an explicitly programmed logic here. You need machine learning here. Are you getting the essence? Okay. So as I said, wherever there's a lot of data present and there's a human present, you can always replace that with machine learning. Legal services has like so many rules are there, so many documents are there. It's not humanly possible to read everything, right? That's why you can employ machine learning in legal service and so on. Okay. Now, so let's say example of machine learning here in LinkedIn, right? So this is a profile of a candidate, and these are the set of features of this particular candidate. And using these data points, I can classify him whether he would want to go into digital services or he would want to go into data products. Okay. Example of machine learning in Google. It's a very classic example. For example, if you are typing data SC, now I'm getting data scientist, data science salary, data scientist jobs. Now for a person who has a lot of search history in data science, this may be the recommendations. Now someone who has a lot of search history in data security, then these recommendations may be different. That's why a Google will always give you different results for different searches for different people based on his search history. Okay. Now and that's why the website tracks your cookies, and that's why it tracks whatever you have visited, whatever pages you have visited in the history. Okay. Okay. So this is done, and so we have already discussed all these things. Now we will primarily be using Python for machine learning. Why specifically Python is basically it's being widely used by the data scientist community because one, it is open source, so you don't have to pay for licenses. As it is open source, it is being used by a wider community, and since it is being used by wider community, it is open to development. Okay, so anyone who wants to develop some code is can do so in Python. So that's why there are so many libraries, there are so many functions already there, that it makes our tasks extremely easy to code. And that's why when we go for an example that we will see here, you see that machine learning coding is extremely easy. It is very different from application programming. Just for the example, the black hole image detection was done in MIT, and that were the primary language that was used was in Python. Okay, so this is the scale. In fact, every industry is using Python for their machine learning tasks. Okay, so let's go ahead. So here, for example, if you want to implement a hello world problem in Java, it's very complex. In Python, it's very simple. This is a very basic difference. Okay. Now, as I said, there are out-of-box libraries that are present in Python, which makes your day-to-day job very easy, and you don't have to code that much. So Python is among the top 10 most used languages in the world, loved by data scientists, default programming language for data scientists. So, I mean, whenever you are applying for a machine learning job, your Python skills will always be tested, and it will be very much valued compared to any other language. So certain resources that you could definitely use, one is the elements of statistical learning. Now, machine learning is all about statistics and maths. Okay, and as a trainer, I am very particular about the background of a model. Okay, so there would be many trainers who kind of give you just an overview and they will teach you how to code, but that's not enough. Trust me, that's not enough. A well-tuned model can beat any model which is any fancy model which is not tuned. For example, a simple linear regression can outperform a very well-tuned simple linear regression, I must say, can outperform a very badly tuned deep learning model. Okay, so it's not that you always have to use deep learning, especially Russians. Russians are known for their maths, and they use very simple models, and their models can outperform the complex deep learning models that people build. So tuning and maths is very important for the model. Okay, so basically the course curriculum will flow like this. You will first 1 or 2 classes would be about the Python and machine learning introduction, and we'll start slowly with the simple models like linear regression, logistic regression. Then we will go on to some complex models like decision tree, random forest, k-nearest neighbors, NAIVE. Okay, so Nikos has a question. Python is so slow, and if you have to analyze big amount of data, it will take forever. What is your opinion? So Nikos, Python is a language. Okay, so it is not a platform. Now, as you're saying, if you want to process large amounts of data, you would essentially use PySpark. Okay, PySpark is more of a distributed distributed processing system, and there you implement Python. So Python is a language. Okay, so it's Python as such, it cannot be slow, right? It's a language, but when you are processing huge amount of data, you need the kind of platform which needs to be different. For example, Spark. Spark would enable you to process large amounts of data, but Spark itself would be written in Python. Okay, PySpark, for example. PySpark is a module in Spark where you write your codes in Python. So Python is a language. Don't confuse between a platform and a language. Platform, for example, a Python in a 2 GB machine would be definitely slower than Python in a 16 GB machine. So Python as such does not have any characteristics of slow or fast. It's the system on which you are doing your processing, right? Now Python can also be implemented using multiprocessing. So you can use all cores of your machine Okay, you can use multi-processing in your Python, and you can process large amounts of data, right? So it's about the processing rather than the language. Okay, is that clear? Okay, so so we were talking about the models that we will go through, the NAIVE-based, the support vector machines. Very important one, the model tuning. As I said, every model we do, we will tune it to the best possible way, and then we'll move on to a complex model. Then we will also introduce you to unsupervised learning. Not exactly introduce, we'll go in very depth of each of these parts, like the k-means, clustering, principal component analysis. We'll also have a project work at the end of the session, and also we will give you a project which will continue after the session. So that's of your interest. You can get in touch with me even after the sessions end, and that's one of the USP. So we'll come to that point later. And the last two classes will be about natural language processing and deep learning. So it's more of to gauge your interest in these particular topics. And then we would also have separate sessions for deep learning as well, which will be covered in a different module. Okay, now, so in short, this is the course plan that we have. So week 1, as I said, would be Python basics and advanced training. Second would be machine learning introduction, linear regression, polynomial regression, regularization, bridge and lasso. Third week would be logistic regression, decision trees, random forest, bagging, boosting, KNN. Fourth week would be NAIVE based, SVM, model tuning, unsupervised learning, k-means clustering. Last one would be LCA and project work. And the week 6, 2 classes would be NLP and deep learning. Okay, any questions on this? Okay, so the course is going to be of 6 weeks. So we have 30 hours of the course. So Saturday, Sunday, 2.5 hours each. So 5 hours 1 week, 6 weeks, 6 into 5, 30 hours. And in each of this, in each of these models, we'll not just see the maths. We will also be seeing the code behind it. We'll see the tuning part, and we'll do a hands-on implementation as well. As far as the pace is concerned, we have had around 10 iterations of the same training, and everyone has been fine with the pace. Nonetheless, if we are going too fast or we are going too slow, we can always skip or add any model that we want to do according to the according to the sentiments of the batch. We can adjust the course, so that's not the problem. One of the biggest USPs that our training has is that we are having live session with the trainer. So I'm going to take your live session. We also are recording the backup of actual classes. So we are not just giving you the recordings of a template, but it's the actual live classes. So in case you miss it out, you can also hear out the questions that were raised during the session. Full time in touch with the trainer. So we would have a WhatsApp group where I will be in constant touch with you. Any questions, any suggestions, any topics that may interest you, articles, we'll be constantly sharing. Post project work and doubt clearance support even after the 6 weekend session. So you will have a project which will continue even after the 6 weekend sessions, and I would be available for any doubts that you may have in that particular project. Apart from that, in case I have in all the previous iterations, I have been in touch with my students, and whenever they faced any challenge in the industry, in their job, how to implement or how to find use cases of machine learning. Because see, learning this part is not enough. You have to go there and implement it, and to implement it, you have to find use cases that needs to be done, and that needs to have business justification, right? That's where you will learn, that's where you will implement the machine learning. Okay, so we will also cover that. So it's a constant relationship. It's not a 6-weekend relationship that we will cover. Okay, so I think we had some questions. Let me address those first. How long is the course going to be? I think we are clear on that. How, are we covering too fast? I think I answered that. Will the materials be sent to us? So materials like what the general template is, basically I will have some slides on which we will be broadcasting. I have my iPad on which I will be mentioning the notes. I will do the maths. I will do the back end of the model. I will have a Jupyter notebook or a Spider notebook, or on which we will code and do a hands-on. All these things will be sent to you, and also the recording of the sessions. Yeah, someone had some question.
Is there any mini project, sir?
Yeah. So there would be a project that would be introduced at the end of week 5. So you will have that week to complete the project. That's a mini project. And after week 6, you will get a project that you would be doing on your own. But of course, we will be in the back end to support it, right? So in case you have any doubt in that project, so you have in total 2 projects. One is a mini project. One is a little bigger project that we will continue even after the sessions or the classes end. Ayush asked, will we be requiring some additional books? I don't think you will be requiring any additional books. I could share some PDFs, but the classes in all will be very holistic, and you could always come up with any doubts you have that you may have read in the books. I can provide you with some PDFs which I have, which are good for starters. Okay, cost of the course, will come to that. That is that will be discussed later after we cover the agenda. Where can I find the recording? So the recordings would be will be shared on Gmail, Google Drive, so you can definitely access through that. Okay, any other questions? Okay, so let's go ahead. Okay, so I've explained the training plan. This is how it looks like. If anyone has any questions, you can always ask me, but this is how it looks like. You will have 5 hours each week, recorded video, some homework, then we'll meet again on the second week. We'll discuss the homework. We'll little bit revise on the previous week, and then go ahead, and this is how the flow will be. Okay, so some of the testimonials about the people who have gone through this training and enjoyed it. Yeah, so that kind of adds to our success stories. Requirements, nothing much. You need basic level math skills. You need a desktop computer, Windows, Mac, anything would do. Prior coding, scripting experience is nice to have, but not mandatory. As I said, Python is very easy to learn, is very easy to grasp, especially the machine learning part. So even if you don't have any coding experience, don't worry, we'll cover that. Okay, so anyone looking to kickstart their career in data science and machine learning is welcome. Any developers and testers who want to change their career or get into a different vertical. So in my organizations, people have moved from software engineering to data science, and they have got around like 100% or 200% pay package rise. So it's very, and this is the skill that is in demand in this particular field now, and it really adds to your CV. Okay. Project leaders, managers who are managing a team of data scientists, they need to learn the basics of it. Otherwise, you cannot manage a machine learning project without having basic skills of it. Okay, not even basics, you need to have some hands-on experience on that. Okay. Okay, so after this course, you will have Python as programming language. Python, you will be performing machine learning using Python. You'll have a proper understanding of machine learning. You will have a proper understanding of unsupervised, supervised both. You'll be able to use cross-validation to tune the accuracy of the model. As I said, that tuning of a model is very important. Lay the foundation for learning natural language, and lay the foundation for deep learning. Okay, Okay, now let's start with one of the models that we might want to cover today. So basically, we are starting our journey with a linear regression. Now, let me share my screen using an iPad so that I can explain you via notes, and it will be easier for everyone to understand that. Okay, just give me a moment. Okay, so there's some issue with the anyways. Okay, so let's understand this particular linear regression, and then we'll go to the maths of it. So basically what we have is a linear regression is a very simple concept wherein we are kind of finding a line, linear, that says a line, and suppose you have one of the very major or popular data set that is in Kaggle. One of them is the Boston house pricing data set. So let me open the Boston housing data set and explain you what it means. Okay, so this is the Kaggle environment wherein you can go in and search for any particular data set and just start implementing your machine learning algorithms. It's a very good way to start, and it's a very well appreciated platform wherein if you have a good rank, people will directly recruit you from your rank on this particular platform. It's a very, very popular platform. Okay, so the problem here is basically there are houses in Boston, and you want to predict the price of a particular house given the data about the description, given the data about the house. Okay, so some of the data that we have is like crime. What is the per capita crime rate in the town? The proportion of residential land zone for lots over 25,000 square feet. Okay, so you have certain features. Okay, I'm not going to read each of these features, but just the essence of it, you have certain features like 1, 2, 3, around there are I think 13 features here, and here you want to predict what is the median value of the owner occupied homes in $1,000. Okay, so this is your problem. Now there are multiple ways you can approach this problem. You can use different models, but for our understanding, we'll start with the linear regression model. Okay, now to start with a basic understanding, let's say you have plotted like against the house prices, what is the, let's say or let's say this is the average, let's say, just let me open this one. Let's say this is a tax. Okay, full value property tax rate per $10,000. Okay, so given the tax rates, you want to check what is the price of the house. Okay, so let's say this is a very simple problem with only one feature. Okay, so this is your simple linear regression. You are not even implementing multiple variables. You have a single variable and you want to predict what is the price of the house. Now, without plotting, without doing anything, this is the data you could have plotted. Okay, so this is the data you have plotted on a XY graph. I want a line. This is the line. Now, how did you construct this line? there should be some maths behind it. So I want a line so that the distance between the perpendicular distance between the points to the line is minimum for all of the points. So what are we trying? This is called the RMSE, root mean square error. What we want the line to be constructed in such a way so that the perpendicular distance between the points and the line should be minimum. So this is your loss function of a linear regression, also called the RMSE. Now you will do some maths if you want to do it like using a pen and paper, or you can leave this to your computer and he will do it automatically and plot this line. Okay, so this is very simple form of linear regression. Now you can have multiple variables, you can have n number of variables, but at the end of the day, this is the line that you're trying to plot. Now, how does this help? Now, suppose you knew in your previous data, you knew that this house was priced at somewhat, let's say $100,000. This house was priced at, let's say, $300,000. Now there's a new house with, let's say, $200,000. What is the price you are going to predict? Okay, so did you understand the essence of the problem? You had in your previous data, you had certain data about the houses, the price of the house and the tax of the house. Now, given a new house, given a house which has a tax, let's say $200,000, you are trying to predict what is the price of this house. Okay, so you have drawn a line. Now, once you get the line, you have the equation of the line. Now, once you have the equation of the line, you can directly predict the value of this particular house. Okay, now does this make sense? Now we will see this implementation in Python. Okay, since we don't have much time, we'll just quickly go through this particular code, and since people are not very conversant with Python at this point of time, I'll not focus too much on the code at this point of time. But you see, a 59 lines code can solve this problem. Okay, so you had your this part is importing the packages. So these are set of functions which are already present in Python. So all that I said, RMSE, calculating the loss function, all these things are being calculated using these functions. You are just importing them. Okay, you are structuring the data. As I said, you are doing some cross validation. Okay, what is cross validation? We'll come to that later, but just to understand at this point of time, you are doing some cross validation. You are splitting the data between train and test. So basically you are using the train data to train your model, and then you are predicting the new data point on the test data set. Okay, so this is how you are. So this is the line where you're predicting, and this is the line where you're fitting the model. Okay, lm.fit x train and y train. This is the part where you're fitting the model, and this is the part where you're predicting, and this is your plot. Okay, so this is the output that you get. Okay, so we'll not go too much details into this at this point of time, but it's more of how the course will progress and how we will understand each of these things in detail. Okay, okay, so let's go back to our slides. So this is one of the models we just started. Now we also have logistic regression. Now, any idea what is logistic regression? Just a wild guesses. Okay, so logistic regression is kind of a linear regression model, but for classification problems. Now, in the starting, we had defined, yeah, very good. Tanuja has rightly said, has a step-up function. We'll understand these, what are these senses, but essentially logistic regression is a type of linear regression, but for classification problems. Okay, don't go by the name, regression. It's a classification model, and it is almost the same way the linear regression performs. Okay. Now, going ahead, we'll also exactly, Siddharth is right. Logistic regression used when we have probabilities in output. So when will probabilities come? The probabilities will come when we have a classification problem. Okay, in regression there is no probability. In classification we have probabilities. Okay. Now we will also go through decision trees, how they are constructed, what is their code, what is the maths behind it. Okay, and how they are different from linear regression, how they are better than linear regression or worse than linear regression. We'll understand those things. Then we'll go into random forest. Random forest is an essentially an improvement over decision trees, right? How what is random forest, how it is better than decision trees. Then we'll go on to bagging and boosting. Okay, bagging and boosting are very powerful models which improve the tree-based algorithm like anything, right? So we'll understand these particular concepts also. K nearest neighbors is another model. We'll understand what is a Voronoi diagram, how are these boundaries calculated, okay, how are they classified. So a lot of things we are going to see in this particular course. We'll also understand the NAIVE based algorithm. What again, any guesses how is the NAIVE based used? Is it a classification problem? Is it a regression problem? If you see this equation, can anyone guess? Excellent. It's a classification problem. Why? Because we have probabilities to deal with, right? So basically what it is saying, probability of a class given the features of X is equal to the likelihood of the function and the class prior probability divided by the predictor prior probability. Now we'll understand in detail with examples when we go through the course. Okay. So, and very important is the assumptions behind each of the models. What are the assumptions? What are the assumptions in a linear regression? What are the assumptions in a decision trees? What are the assumptions in a NAIVE base? Okay, so we'll understand why is it called NAIVE base. Okay, so everyone might have heard Bayesian theorem in probability. Why is it called a NAIVE base? Okay, we'll understand each of these concepts. We'll understand support vector machines, how they can help in such cases where no other model can help. Why are they unique, so unique? Okay, so this is what we would go through. Then we'll enter into unsupervised learning scenario wherein we will understand k-means clustering. You'll understand PCA. We'll learn to plot very beautiful graphs so that you don't have to go into Excel and do this. You'll do this in Python. We'll be primarily using Jupyter notebooks and understand its functionalities. Last couple of classes we'll be going through the natural language processing, how natural language. Yeah, any question? Okay, so we'll go through natural language processing and deep learning. Okay, so these are very interesting spares, but this is not the agenda of our course, but we'll just introduce you to NLP and deep learning. So yeah, we will be getting the recording of each of the sessions and each of the live sessions that have been taken, right? So in case you miss even one class, you still have backup. And don't worry, we'll keep on revising the prior classes, so you don't have to, you know, and don't get panicked that, hey, I missed one class, how will I understand the continuation? Don't worry about that, I will handle that. Okay, now what is deep learning? Basically, deep learning is a very interesting topic, and when we also have a separate course on this, but just to get you excited about this topic, deep learning is basically an implementation by a Stanford professor. He said that if we are saying that machine learning is an analogy to a human learning from experience, why don't we build models that mimic the brain of the human, right? So if a human brain can learn so many things, how can we replicate this model in mathematical form so that this can be used to do machine learning. And with this particular philosophy, he kind of created machine learning, a deep learning environment. And you won't believe, deep learning, and I'm not even bragging, but deep learning, if you read through news or read through articles, deep learning, certain algorithms have outperformed the best humans in the business. For example, AlphaGo is a game. It's kind of a Chinese, it's kind of a chess game, and AlphaGo deep learning model has beaten the best human. I forgot his name, but the best in the business. He has the computer has beaten the human. So this is how deep learning is extremely powerful, and for unstructured data. Okay, and as I said, it works on the concept of neurons, like the human brain. Why is it so powerful? It can understand the relationships of the features within the model. So for example, when you are predicting, let's say you are seeing an MRI scan of a tumor, and you want to predict whether the tumor is cancerous or a benign tumor. Okay, now why is this very important? So for example, a very good doctor, an extremely good doctor, may be able to figure it out by just seeing the tumor and not seeing the results. He can just figure it out whether it's a benign tumor or a cancerous tumor. Now, a not so good doctor will not be able to figure it out. He'll do a biopsy, he'll do different tests, and then he might be able to figure it out. Now, how did the very good doctor figure it out just from seeing the scans? Now, being a doctor, he has some experiences, he has some features in mind. Features in the sense, how is the tumor sized? What is the shape of its boundary? How are the boundaries? Are the boundaries very distinct, or the boundaries are very phasey? Now, these things are features, and these features the doctor is learning from the images. No one has told the boundary. No one has told him the boundary shape. No one has told him the boundary length. No one has given him figures. He's just seeing them, and he's just from the image he can understand. Similarly, a deep learning model functions like this. You just feed him the image. You just feed it the image of a dog, and it can say whether it's a dog or a cat. You don't need to say that this has four legs, this has fur, this is a very good pet for human beings. You don't have to tell him the features of the particular image. You just have to tell him send the image, and it will give an output. That's how powerful deep learning is. It will understand the features from unstructured data. Okay, and that's why it differentiates itself from machine learning. So feature extraction in machine learning is very important. Like I showed you the Boston pricing data set, it has clearly defined features, that this is feature number 1, feature number 2. Feature means the attributes or the variables. Okay, now in deep learning, it's not necessary to tell the features. Okay, so that's why deep learning is an excellent form, and is the only form which can understand unstructured data. Okay. Applications of deep learning in real world is that, of course, the common ones like Apple Siri, Google Translate, Amazon Alexa. In the deep learning class, if you guys join, we would also create something like an Alexa, which can recognize your voice and tell that, hey, this is this guy, or this is this guy. So we can also implement a kind of an Alexa or a Apple Siri. Okay, Face ID, autonomous cars, taking picture of a black hole. So this is also now, if you ever are interested, just go into the TEDx talk where they talk about how they constructed the black hole, and it's an excellent example of deep learning and Python. Okay, so let's go ahead. Platforms for deep learning, there are many: TensorFlow, Caffe, Keras, Theano, PyTorch. TensorFlow is one of the most widely used. Okay, there are different models, but widely there are ANN, artificial neural networks, which are used for mainly used for structured data. Recurrent neural networks, these are called sequence to sequence models, where you have sequence of data. For example, voice is a sequence of data. As I'm speaking in a sequence. Natural language, like when you are talking, you are speaking out sentences. So sentences is a sequence. It's not haphazard. You cannot place a verb at the starting and a pronoun at the end, right? The sequence will break. So that's where the sequence to sequence data is important. CNN is a convolution neural network, where it implements image data, or it can read through images and classify whether it's a dog, cat, etc. Okay. Logistic regression versus artificial neural networks, an example. So a very important distinction why I had put this slide is basically, you see, suppose you have some kind of data like this, where you want to classify between the blue classes and the red classes. Now, if you implement a logistic regression, okay, the best boundary, if you see on the left hand side, the best boundary you could see is the line which divides between a blue and a red. Okay, now this has a lot of errors, right? Because in the red zone there are blue dots, in the blue zone there are red dots. So this is not a good classification that you have done. However, if you do a similar kind of thing in using artificial neural networks, using having a number of hidden layers, what we call in deep learning, you see the same problem can be tackled in a much better way. Okay, so that's how the difference between this lies. So logistic regression can create only one boundary at a time. So either this boundary was this, or this boundary could have been perpendicular, but at any time you would be failing to classify this properly. But in the form of artificial neural networks, if you can classify this in a much better way, and this error reduces. Okay, so this is very simple example of a difference between logistic regression and artificial neural networks, but this is how powerful your deep learning is. Okay, so basically I'll hand over this to Ashok. Ashok, are you there? Ashok, can you hear me? Okay, so by the time he
unmuted,
just go through this, yeah. So I think it's time we kind of give the guys the timeline. So the training will start from next Saturday, that's 7 September 2019, and we will go on for 6 weekends as we had promised you. The timings will be as mentioned are here. So according to your time zone, you can just note it down. And any questions you have on the training before we proceed?
Sir, will you provide any placement assistance?
Placement assistance. So I think Ashok will be a better person to answer that. So yeah.
So can I know the name, the person who asked this question?
Vamsi.
Bamsi. Okay, so we have many clients and we are connected to many HRs and likewise. So we keep getting requirements, and if you fit in any requirement, we will definitely try to share that requirement. But we are not the type of people who will say we will place you, just get trained with us, because this is a very demanding skill in the market, and the learning that we are going to give you will definitely lend you whether in changing your career, or if you are starting your career, it will definitely help you. Yeah, definitely we will help you, but we don't say like that we will place you, then only you take this training. I hope you understand my point.
Yes, sir.
Yeah.
Ujjwal had some questions. So what are the key factors that companies demand for in our CV for a data scientist profile? Okay, very good question actually. So a CV would essentially have Python. First of all, they would look for expertise in Python. then they would essentially see what are the models that you have implemented or have knowledge of. Okay, they would understand, they would also appreciate what is the why you have used the model. It's not just what model you have used, but why you have used the model. And as I said that cross validations. Okay, so they will use ask you what is the score that you might have got with this model or have got this with this model. So essentially the details of each models. Now when you land into an interview, they will definitely ask the working of the model. Very out of 100 interviews, 90 interviews will ask you what is the background of the model, what is the maths behind it, which we will definitely cover and which I will focus my most of the energy in. 10% of the interviews might ask you to code. Okay, that they might give you a data set and ask you, okay, write the code and understand this, which to be very frank, I don't think you need any training on that. Okay, you can go into scikit-learn, github, you can just copy paste the code, which is not a problem. Okay, but to understand the maths behind it, that's where I think this training is I proudly say this, that this training will be very focused on the background of the model. I will definitely take you through the codes, but that's not the important part. Many trainings will start from the codes, and you know they will tell you this is how you code, but that's very easy. You can just Google search and do that. And if after the session, it's what you make out of the session, right? Because even after, let's say, even if I teach you the codes, after 2 months you might forget that, you might have to Google it. But what I will teach you in the form of the background of the model, the maths behind the model, that will remain with you forever. And trust me, whatever model comes in in the market, whatever model comes in, the maths will almost remain same. Okay, so I think if you any guy wants to interact with our previous batch or previous to previous batches, they can always vouch that yes, Shubhodeep taught us the back maths of the models, and I am very clear on that. Okay, so Ashok, you can take the next slide. Okay, last thing, deep learning webinar we are proposing on 15th September 2019. Although it's not a fixed date at this point of time, we'll update you in case this changes, but this is what we are having. So we will go through the what the deep learning course might have to